Hey guys, welcome to AlgoYogi, and today we will be solving binary tree post-order traversal. We have already solved in order and pre-order. You can check the solution or solve them and mark them solved on AlgoYogi and start tracking your problems. So let's just go to our problem on LeetCode. And the problem description is very simple, and I'm sure you already know if you have done pre-order and in order. The post-order traversal is visiting the node in left, right, and root. That's the order we will be visiting our nodes in. So let me switch the view here, and I'm sure you already know the recursive solution. So we'll just briefly discuss that, and then we will get into the iterative solution using our stack. So now I've drawn this small tree here. So post-order traversal will be basically visiting our left node or left subtree, and then we want to visit our right subtree or right node, and then we process our root. So now here in recursive solution, you will just have a base condition checking if your root is none. If it is none, just return the control of the program, and then you'll be calling it on your left node, and then you'll be calling it on right node, and then you want to process your root. So I know, I'm sure you have done it, and we will write the solution when we go back to the Python implementation. However, before our Python implementation of recursive solution, let's just go over the iterative solution also, the approach that we will be using. So here, like in order and pre-order, the reason iterative solution for them was simple is because we were either processing left or root first before going to the right side. And going to the right side mean we will never return back. Like, we don't want to come back. We have either processed our left, or we have taken care of the root before going to left, or we're going to take care of the root after coming back from left side, just visiting one side and coming back. And after that, we're going to the right side, treating that as a completely different tree. And the reason I'm saying it that was easy is once you're done processing, you don't have to come back to the root in order to process it later. So that made our in order and pre-order easy. However, this one is just little complicated because this time what we really want to do is we want to process our left node or left subtree, and then instead of processing a root, or like first processing a root or going to left subtree, we want to process right, and then coming back we want to process root. So that means every node is being visited twice. In that way, first time we are visiting it, we're not processing it then. What we really want to do is we want to process its left, we want to process its right, and when we come back here, then we want to process it. Okay, and then we want to process it, and after that here, this is not where the control will go now. So this will be treated as just like we processed this side first, this side, and then we process this. That's how we will be processing right side, and then we come back to the root. So let's create a stack just like we do in the other problems. This time we will be processing the node when we are visiting it twice. So let's just keep a visited set as well. So we'll have our stack, and we are putting our root in our stack. So let's run it on this example. I just want to quickly run it on this example, and it should be clear to you guys. Okay, so I'm going to put my root here, and then I will have a visited set. Now I will start this while loop that if my stack is non-empty, then I will have a current node pointer. And in my current node pointer, I will pop what is in my stack, which is currently its root. Is root visited yet? No, it's not visited. I'm visiting it right now. So I pop it out. It's on my current node. If my current node is basically, if I'm popping it, like it might not happen that it's always not none. So I'll keep a check. If it is not none, then I want to process its left, and then I want to process its right. And in order to process those, what I'll do is I'll put my current node back to my stack so that I'm visiting it again. I'm coming back to it. Okay, so that I have that reference. I know it's like little, difficult to think in a way, because it's like little different than doing pre-order and in order. And this is the first time I'm just running over an example. So we're just doing it together, right? So let's just see if it will give us this order, and the order will be visiting 2, visiting 3, and then visiting 1. That's how our order should be. So let's just have our answer that we will get from our approach. And the approach is simple. It's not simple. We'll try to make it simple. Okay, let's just have it now. Because I'm visiting it, so I'll add it to my stack, and then I will add the right side to my stack so that I'm processing it after my left, and then I will add my left. However, before that, I'm adding it to a stack, so I'll add it to my visited set also. Now, what I'll do, I'll add my right, which is 3, and then I'll add my left, which is 2. Okay, now I'm done visiting the root. I'm done visiting the root. So basically, I was visiting the root, and I will have to do that for all the nodes. Okay, so now I go back to my while loop. Stack is not empty. I'll pop 2, but 2 is not in the visited set. That means it's not. We haven't processed it. Even now we haven't processed it. So let's process 2. In order to process, we know it. Let's add it to our visited set, and then process its right and left. So right is none, we're adding none, and then left is none, we're adding none. Let's just go quickly, and then we're done visiting it once. We'll be visiting it twice, okay? But the mistake we did is before we add left and right, we have to visit that. We have to add it to our stack as well, and then we have none, and then we have none. Now we're done with this node. We go back in the while loop. We pop out n is none. So we just gonna simply take care of it, those 2 none. And then we pop out our 2. And this is the first time we are visiting 2 twice, because we will check on our visited set, have we visited it? And if we have, then we're gonna add it to our answer. So this is what we do. But this time, because if it's already existing, that means we have already processed it. We have processed it. It's left and right. So we're going to just simply get out of this and go back to our processing our stack values. Now we will pop out 3. Let's pop out 3. And 3 is 1. We haven't processed it. So let's process it. Processing means adding it to our stack, and then also adding it to our visited set, and then adding its left and right. We're adding left, and first we'll add right and then left, because we want to visit them in, we're popping from the back, so that we're visiting them in the right order, which is left, right, and root. So again, the same thing is going to happen. We'll add none here, but we don't have to go there into none, because we'll have to pop them and do nothing anyway. So next time we will be popping out our 3. Let's just take it out from here. 3, we have already visited it, so we'll add it to our answer. We're done with it. Then we pop out 1. It's in our answer, and then we pop out from our stack, and we will check the condition. Stack is empty. Get out of the loop. Return the answer. Return the answer like this. Okay, so let's go to the implementation now, and we will be implementing the recursive function first. Or let's just do the iterative function first, and then we will do the recursive function. So let's change the view. And for that, we will be having a stack. And initially, our stack will hold the root, and we will have a visited set, okay, to keep track if we are visiting the node second time, so that we can add it to our answer array. Okay, so while condition, while stack, we want to have our current node popped out, the current node that we are processing. Not adding it to our answer, not visiting it twice, but processing. Processing means the way it's left, the way it's right, and before that, before doing its left and right, just also put it to the stack so that we will be visiting it back, and we can add it to our answer because it will be left, right, and root. So let's pop it out from my stack. Okay, if current node, what we want to do, I want to check if it's in the visited set. If current node in my visited, that should do the job. Then I want to add it to my answer. Current node dot val. Okay, great. What if we haven't visited? Then we want to process it. And how we process it? First is let's add it to our stack, our current node, and mark it visited. This is the first time we have marked it visited. So that second time we are coming back to it from the stack, we just process it, we just check this condition, add it to our answer, and get out of here. Like, just don't bother about current node. Later the current node will become the next element we pop out of the stack. So I think this is clear, right? Okay, so visited.add current node. Okay, what else? So we talked about it. Then when we are processing a node, we want to add its right child. We want to add its right child first. The reason is so that we can process the left child first. You know why? Because we will be popping the elements from the back. So we want to add the left child after the right child, so that we're popping left first and then processing the right. Okay, so this is good. Now I think this is all good. So simply let's just return our answer. If our logic is right, then this should run fine. Let's just check it one more time. Our stack is starting with our root, and then we're popping it to our current node. We're working with current node. If it is already visited, we're adding it to our answer. If it is not, then we're processing it. We're adding it to our visited set. Processing right, processing left. Okay, let's try to run it. And no, it should not be add, it should be append. Okay, simple mistake. So runs fine. Let's try to submit it. And done. Okay, let's write the time complexity. Time complexity will be big of n, because we are visiting each node twice, but it comes down to big of n only, n plus n. So it's not for every n I'm visiting it n times. You know, it's not like that. Space complexity would be big of also big of n, because I'm adding it to my visited set and then stack also. So adding it twice, so it's like 2n. It would be 4n, but again it will come down to n. Now this is the iterative solution. Go back to the concept if it's a little difficult to understand right now, but I think the way we went over the problem, you know, on the iPad, it should be easy to understand. Okay, let's also write the recursive solution as well, because we said we will. So that will be simple. Okay, we'll have just our answer array, and then we will have just an inner function. Let's call it post order, taking root, and then base condition will be if root none, then I want to just return. Otherwise I want to do post order root.left. See, this thing is very easy. Recursive solution is really easy. And root.right. And then we just want to process the root now. So answer.append our root.well. Call the function. I mean, it's simple, right? Let's just call it on outside the inner function and return the answer. Time complexity and space complexity will be same, big of n and big of n. Space is because of this implicit, stack that it's using by. Also, it's like happening internally by machine, but we know it is using big of n times because putting every node onto that stack and then processing it after it reaches the base condition, start coming back and processing those nodes. Okay, so let's submit this answer as well, and I hope this will get submitted. Runs fine. Okay, let's go back to our AlgoYogi, mark it solve, and then I'll upload the solution over here. If you guys wanna go to the solution right from here instead of searching. Okay. Okay. Bye bye. See you in the next video, which will be inverting the binary tree. Easiest of the problem, but we'll do it later, right? One by one, slowly enjoying the process. Okay. See you. Bye.